We finished up the definition of the derivative, right? Now we're going to start studying the rules. This is going to make finding derivatives a heck of a lot easier. First rule, the constant rule. Derivative of any constant is 0. Makes sense if you think about the derivative as the rate of change. Constant's not changing. Power rule. Derivative of x to the n x to the n minus 1, as long as n is not 0. What the hell is that? The sum difference rule. Derivative of a sum or difference of functions is the sum or difference of the derivatives. Constant multiple rule. For any constant k, the derivative of the constant multiple of a function is the constant multiple of the derivative. That's either upstairs or it's the actual window itself. These two properties together are what are known as the linearity properties. So the idea of linear operators is studied way more in depth in linear algebra. Suffice to say for right now, differentiation is a linear operator. It's a linear operation. Now this is where things become different. Looking at this, first instinct would be the derivative of a product of functions would just be the product of the derivatives, which is incorrect. Derivative of f times g, g times f prime plus f times g prime. And the order here doesn't matter, right, because it's addition. What if you're given a quotient of functions? Once again, it's not going to be the quotient of the derivatives. Derivative of f over g. G times f prime minus f times g prime all over g squared. Storeroom. These rules allow us to differentiate polynomials and rational functions very easily now, as well as any function that involves powers. So any power function as well. That also happens to cover all but one of the function operations learned in pre-calculus. There's still one operation left. That's composition. That we won't study till next week. And again, this is where the shorthand comes in, where we just say derivative for derivative function. What's the derivative? And that's just 0, isn't it? That was easy. What is 2 to the 40th? A very large number. I'm actually not sure if your calculator will give an overflow error on 2 to the 40th.
Google can. Way to find out, I guess.
It's
1,999,000,000.
What is it?
1,099,000,000,000.
Okay, only a trillion. It's only a magnitude of 10 to the 12th. That's fine. Yeah, that's not an overflow error. Try 10 to the 40th, though. That will give you an overflow error on a calculator.
Oh, this one didn't.
10 to the 40th?
Yeah. It's very big, not that you can see it from back there. But
I'm surprised I didn't give an overflow error.
you can try 100 to 40th.
I think 10 to the 100th is overflow.
Oh, 140 didn't either. I don't think it's computing it all the way through. Right?
Well, it's applied because it's doing just 1e
Yeah.
to the 140. Whereas if you do something like 25
We do 900.
to the 40th,
I did 1,000 and still went. I did 999 and still went through.
that's surprising. And we'll never deal with numbers that large.
Oh, yep, I broke it. We put 1,000 to 1,000, and then it doesn't like that.
If you really want to have some fun, do 10 to the 100th factorial. So for this problem, I'm going to break it down to show you what's going on. Yeah, I probably going to do that after this. So it's a sum and difference. All right, so that's the first thing to notice. Then the second thing to notice is we have scalar multiples. And we have a derivative of a constant. Why do I keep writing 7 halves? We have derivative of power. we again have derivative of a power. So there's your derivative.
You wrote 7 half.
This sum's supposed
Oh,
to
it
be.
is.
Now, this sum's actually supposed to be 7 halves.
Someone's fixing a leaky faucet.
I don't think there's a faucet in there.
Well, I don't know what they're fixing.
It's just a storage closet.
That's what it is.
Not even a maintenance, it's just a storage closet. Say that was so much easier than the definition. So I'm going to take this time to introduce a new notation. My two physics people, pay attention. It's the dot notation. Represents derivative with respect to time. So if I use that, I'm referring to a derivative with respect to time. Very common notation in physics. Go term by term. Derivative of t to the fifth with respect to t. Because the respect to is important. No, just t to the fifth for right now. Now times that by 1.4. T squared times 2.5. 6.7. There's your derivative. Finally, derivative. Two ways to go about this. First is to use product rule. Is it mandatory? Obviously not, because there are two ways to do it. So what do you think the second way is? Expand it out first. That is the path I'm going to take because that was the original intent of this problem. The original intent was to use just the regular rules. I combined two sections into one here. It really just boils down to when do you want to do the algebra. So first, rewrite it. 3u squared plus 5u minus 2. Now, you can find h prime.
6u plus 5.
And there's your derivative. Look at that, it's been, what, 3 minutes and we're through how many problems already? This is so easy.
Excuse me. How do we know once we've arrived at or finished the function?
What do you mean?
How do we know when we're done?
When you found the derivative?
Yeah.
That's how you know you're done. You took the derivative of every term, right?
Oh.
Is it fully simplified? Then you're
Yeah.
done.
All right.
It is just that easy. And in general, derivatives are fairly simple. Integrals, on the other hand, we'll see, they're not as easy. How would you find the derivative of this function? That's how you would do it? What does my friend say who lives in South Town? Bless your little heart. Have fun, I'm not going to stop you.
You could bring the r to the numerator and make the exponent negative.
It's not just 5r to the minus 3. Last time I checked, minus 3 is a number. What is this now?
Exponent.
Which means, what rules?
Power rule.
Just the power rule?
Be negative 15 or to the negative 4th power.
What two rules did you use?
I mean, you don't have to use the quotient rule because you can just bring the exponent up, and then it would just be a regular. You would just use the regular linearity way.
So what two rules did you use?
Brought the negative 3 in front, did n minus 1.
That is what rule? What's the name?
I don't remember exactly.
You may be asked this on the test. That's why I'm asking. So what rule is it to find the derivative of a power function? Power rule. What other rule? There's one more. And constant multiple rule, which is what tells you to then multiply that by 5. And generally speaking, you don't want negative exponents. If the problem gave you negative exponents, it would have been fine to leave it. So negative 15 over r to the 4th. What's dy dx? Now keep in mind that is shorthand notation for this. Go ahead.
5 times the square root of 3 to the third power all over 3 minus 2 over 3 times x to the cube root
What was that first term?
of 5. So 5 times the square root of 3 to the third power over 3.
We said minus what?
Whoops. It's to the cube root and it's squared.
That?
Yeah.
Minus what?
Over 3. All that minus.
So that's just hideous looking, but yes.
Yeah.
So general rule of thumb, they gave you fractional exponents, right?
Oh,
Keep fractional exponents. So the first term would then be that, which is correct. And you said minus, what was your second term?
2/3 times x to the negative 1/3 power.
What rules did you use?
The constant also.
Okay, that's one.
The sum of the
That's two.
Product rule?
What was it?
Product rule?
Power rule.
That's what
I'm not going to keep it that way, though. Because I see a negative exponent. Factor out x to the minus 1/3.
1 over the 2/3.
The nice thing is they also both have a common denominator, 3. So 3x to the 1/3 in the denominator. When you factor out an x to the minus 1/3 from x to the 2/3, what are you left with? X to what power?
1.
First power. How'd you get it?
I kind of reverse engineered it because if it's 3 over 3, which is 1, minus 1/3, it would be 2/3, which is what we have.
When you factor out, you're dividing. Right, so x to the 2/3 divided by x to the minus 1/3, which is essentially what you said. So I'll write it that way. Again, the intent of this was not to use product rule. Product of one do it. Product will be better. No, I'm gonna have to distribute through anyway. I do product rule. I'm gonna have to wind up distributing anyway, so I might as well just do it now. I'm also gonna make life easy and write fractional exponents. Cube root of x is same as x to the 1/3. Take that derivative.
Um, 2/3 x to the negative 2/3 plus 4/3x to the 1/3.
That. We have 3x to the 2/3 in the denominator. I'm factoring out an x to the minus 2/3. 2 plus 4 times what? So x to the negative 2/3 factored out from x to the 1/3 leaves you with what? Said another way, x to the 3rd times x to the 2/3. It's just x. Third plus 2/3 is 1, isn't it? So that's your new power. And just to keep it in the same format, I'll write it as cube root of x squared. What's S prime? I don't know, would it be?
Yeah, because 4 or 5 is constant.
By the way, do you recognize S of R?
Like surface area for a sphere or something?
Which one?
I'm gonna go with volume. My areas, or, no, my answer, you want to change my answer was
It's surface area. Cubic units.
yeah, that makes sense.
So it would have to be r cubed. So volume's 4/3 pi r cubed. Surface area of a sphere 4 pi r squared. I wonder if that will be important. So how do we approach this problem? Not product.
No, I meant quotient.
Negative x, take that x squared, put it on top.
And then what?
Oh, that's just all I had. It's just a good place to start, make it a bit easier.
What rule jumps out immediately? So what type of function is that?
That's a quotient.
So what rule would jump out immediately?
Quotient.
Do we really need to use quotient rule? You can if you want to.
You can just set it to x to the 1/2 power plus x to the -2 power, all in the numerator, in which f prime of that to start would be 1/2 x.
Where are the plus x to the minus 2?
I actually think that's wrong.
It would have come up as a plus x to the minus 2.
Be multiplied.
What were you going to say? Then what would you do? So I'm going to go one step easier. Don't bring it up. Can't you write it that way? Because it's a monomial in the denominator, so that just gets applied to every term in the numerator.
Wouldn't you just have to do the quotient rule twice now?
No.
No.
You just subtract it.
How can you simplify square root of x over x squared?
Oh.
Right? Generally, I wouldn't write that middle step. That's just x to the minus 3/2 plus x to the minus 1. So what's dy dx? What's your smallest power? What is it? You sure? -5 has it smaller, right? That's the one you factor out. You always factor out the smallest power. What are you left with? One half, right? X to the 5 halves. How can you write that in radical notation? Square root of x to the. Is that fully simplified? Sorry, is that fully simplified? How's that simplified?
For the S is in the denominator, bring X forward. Outside of the square root.
Well, you're pulling an entire x to the 4th out of the square root. So you're saying it'd be this. And no absolute value needed.
Where to go from underneath the 3 house?
Hmm?
From 3 house.
Oh, yeah, I forgot it, didn't I?
Oh, okay.
Rewrite this. How do you rewrite the first term?
Five t to the 1/2 power.
Like this?
Yeah, just for the first one.
Oh, you just got
Yeah, the whole group would have to be the 1/2. How'd you take that derivative?
Five over 2x to the power of negative 1/2. Sorry, 5 over 2 times x. And then to the power of negative 1/2.
Saying this wouldn't be x.
Well, I wrote x on my paper just because that's what you
That?
work with.
Or not negative.
What I meant was 5 over 2, and then that multiplied by the t with t on the outside. And then it would be, which is basically the same thing, I guess. Yeah, that's what I'm going with.
Would that be the derivative? No, it's not. You forgot to apply the 1/2 to the 5. Because it's the quantity of 5t raised to the 1/2.
So,
As that stands, you can't take its derivative.
oh,
You haven't learned that rule yet.
okay.
But you can rewrite it to make it possible.
Just distribute the power, right?
Write it that way. Now you can do it. Then G prime. Common denominator is 2t squared. And that's what you'll get fully simplified. Same kind of idea. What's 4 cubed?
Let's see. 4.
Rewrite it. 1/64 t to the minus 3 plus a quarter t. Now allow you to take its derivative using power rule, sum rule, and constant multiple. (64 d to the fourth is common. Oh, wait a minute. That's supposed to be -1, not the first power. No one caught me on that. Oh wait, that's still -3. This just becomes -16 t squared minus 3. Which I don't like the negative, so I just factor out a negative. That would be your derivative. Find the fourth derivative. What's f prime? What's f double prime then?
30x to the 4th.
What is f triple prime? So what is the fourth derivative? There's your fourth derivative. What would that be? Why?
Because you ran out of the x and that's the board.
Let's make a simple change. What is that derivative? Hmm? Is that it? Yeah, it'd be 101 factorial x. Yeah, 101 factorial is a very, very large number.
Still not an overflow though.
And okay, so let's get that one. How would you do this derivative?
I think it's time to pull out that quotient.
Yeah, this is unfortunately a quotient rule. That is the first time I've heard anyone go thank God when they had to use quotient rule.
There's numbers on the screen. I can do this.
Never heard anyone excited for a quotient rule. And I've been doing this for a decade. So again, I'm going to write out the intermediate step for this problem and then never do it again. What did the quotient rule say?
Basically, the bottom formula times the top derivative minus the derivative of the bottom times the top, all over the bottom squared.
What is that derivative? That was your calculus step. Now I have to simplify it.
Should it be an x squared minus 10?
We're going to get what? 4x squared minus a 2x squared. 2x squared. Get a 2x with no other x terms, right? And a plus 4. Can that simplify any further?
If you expand the bottom, you could take a 2 out.
Is there going to be a 2 common in the denominator? You could expand out the denominator. That's fine. By custom, we don't. But you could, right? That would just be what? 4x squared plus 4x plus 1. By the way, what if I asked for the second derivative? You would have to expand out the denominator at that point, because you don't have the rule needed for that. Which means you're going to have a 4x squared plus 4x plus 1 squared in the denominator of your second derivative. What if I then ask for the third derivative? You would have to expand it out again before you take its derivative. So the intent for this problem was to use product. So that's what we're going to do. Again, I'll write down the intermediate step and never do that again. What does product rule say?
The first function times the derivative of the second function plus the derivative of the first function times the second.
I'm going to write it the other way,
That's fine.
just to keep it in line with the quotient rule. But it doesn't matter. Don't throw things at the wall.
Yeah, that makes sense.
Do you have siblings?
Yeah.
Yeah, don't throw things at the wall. Your sibling may accidentally walk in front and then they get hit instead.
Oh, no.
I had a friend do that.
Oh, how-
Got frustrated, was throwing stuff, and one of their siblings walked in the way and they got hit instead of the wall. Except I think she was throwing stuff downstairs and wound up hitting someone. Yeah, so don't do that. Plus, then you have to pay for wall repairs. That's not cheap. Yeah, the sibling will be fine, depending on what the object is. Just get a minor bump. Maybe a concussion, but you know, that'll heal.
No, never concussion, well, you know, not good,
Concussions heal.
not well.
Depends on the severity.
Yeah, 'cause it impacts later in life. Scary.
At least not a hole in the wall.
I'd rather hold the wall.
And of course, notice that the independent variable here is y. That's why it's d dy. Right? What's that derivative? And because we have a test on Monday, I think I will go a little bit longer today and Thursday.
Minus, or plus 4 over y to the fifth.
Yeah, that's a derivative. And what is that derivative?
Well, plus 2y.
There's your calculus step done. Now we have to simplify it. Man, you can shake your head all you want. We have to simplify that. That's why I love math so much. Math doesn't give a crap about your feelings. Distribute. That's what? Negative 2 over y squared plus 4 over y to the fourth minus 10 over y plus 20 over y cubed plus 10 over y squared plus 10 over y. Oh, that's nice. Minus 1 over y to the fourth minus 40 over y cubed. Let's just take care of that right now. 10 over y is gone. That's nice. So let's write it up here. We have a common denominator of what? to the fourth. So y squared then would be the smallest. That's negative 1 over y squared. That needs to be multiplied by a y squared. Minus y squared. Y cubed minus 20y. Don't tell me it's all going to be negative. That's going to be annoying. And then y to the fourths. Oh, good. Plus 3. Still kind of aggravating. That makes me happier. How are we going to do this one? Not quite sure what that means.
Like, divide.
Hear me out. Take that fraction, flip the whole thing upside down, and we have negative 1 power everywhere. But then it's only one term on the bottom.
Okay.
So then it's
But how do you take the derivative of an entire function raised to a power?
I'm not that far.
We haven't gotten there yet. So that's not going to work.
Okay.
You're right, that would be valid
All right.
once we learn what we're going to learn next week.
Got it.
But right now it's not.
All right.
Can we use the quotient rule?
This, you have to use quotient rule. Because it's a binomial in the denominator, you can't really simplify it. And actually, that is a proper fraction. So even long divisions wouldn't simplify it. That's already as simplified as it gets, which is unfortunate. All right, so jingle that I learned. Low d high, so there's your low d high, minus high d low, oh, that's nice. D low is just 1. Over low square. Amazingly, I learned that jingle my senior year of undergrad from a friend of mine. That's not how I learned it in high school. I actually just memorized the order, which is why I hated quotient rules so much.
I mean, what's going to say it doesn't look that complicated, but when you're memorizing a ton of different formulas.
And you also have to remember that these are still pretty simple functions we're dealing with.
Yeah.
Just wait till the fractions get even worse. X to the minus half plus a half x to the half minus x to the half, right? So that's what? Simplifies to minus half x to the half. Complex fraction, multiply numerator and denominator by your LCD. to the half plus a half x to the half minus. Well, that's right. How do I get that then? Oh. That's how. I mixed up where my x to the minus 1/2 was. That looks better. And just to keep the square roots from the original problem, write this. We'll pick up here on Thursday.